like to talk about this exam question. I put it on an exam many years ago, thinking that it would be a gimme, that everyone would get it right, that it would be very easy. The question is, you can tune the frequency of a guitar string without changing its length. To tune a flute, however, you have to slightly adjust the length of the tube. How do you account for this difference? Now, as we were grading that night, we found that almost no one got this correct. And the most common wrong answer that we got over and over again was this: flutes don't have strings. If they had them, we would use them. But they don't have them. More's the pity. Okay? That's not the answer we were looking for. Okay? But it is hard to argue with. Flutes don't have strings. This is what we were looking for. Regardless of whether the wave is a transverse wave on a guitar string or a longitudinal wave in a flute, it has to obey the wave equation. Now, tuning means changing the frequency, making the frequency bigger or higher or smaller, lower, changing the pitch. Now, we have to ask ourselves, in that equation, what can we do to change F? Well, on a guitar string, if I don't put my finger on one of these frets, if I don't push down on the string is fixed in length. And the first harmonic is going to be twice the length of the string. And so there's nothing I can do about that. It is what it is. So that means the only way I can change the frequency is to change the speed of waves on that string. Now, for a transverse pulse or wave, we have this formula. Now, this mass density is just how much mass you have per unit of length on that string. And when an E string comes out of the factory, that's fixed. That's already set in stone. So the only way you can change the speed is by tightening the string. That's going to make the speed faster. That's going to make the frequency higher. If I loosen the string, that's going to slow down the speed of waves. That's going to make the frequency lower. On the other hand, flutes don't got strings. So if I want to change that frequency, I ask myself, what can I change in that equation? Well, these are sound waves that are going back and forth, and so the speed is constant. It's 343 meters per second. Now, I feel silly saying that to a bunch of people who live in Bozeman, Montana. I mean, I had a son who was in high school marching band, and then, tune up their instruments in the gymnasium and march out onto the field and out of tune. Okay? Why? Because it was room temperature in the gymnasium. It was 40 below out on the field. Okay? That's just part of living here. But given the fact that you stay inside the gymnasium, you can't change the speed of sound, okay, without turning the thermostat. And that means I need to change the wavelength in order to change the frequency. The smaller I make the wavelength, the higher the frequency. Now let's understand what that means. If this represents my flute, open at both ends, and I want to tune that, I want to make it a different frequency. Do I want to lengthen the tube so that I can fit more footballs? Or do I want to lengthen the tube so I can get bigger footballs? Which is it? Talk to your neighbor. I want more footballs or bigger footballs?
I think that's a coincidence.
Okay.
Well, what's the difference?
I hope everyone said you wanted bigger football. Look at this equation. The speed, it's a sound wave. The speed is fixed at 343. The frequency times the wavelength, but a wavelength is 2 footballs. So, if I have the same size footballs, I've got the same frequency. Listen to that again. If 2 instruments have the same size footballs, they are playing the same note. Okay? This instrument and this instrument have the same size footballs. They are playing exactly the same frequency, the same note. That one's playing it as the first harmonic of its instrument. This one is playing it as the second harmonic of its instrument. But it's the same note. Okay? In your homework, you had 2 tubes. A tube A and a tube B. And tube A was open at both ends and tube B was closed at one end. And you were told that they were playing the same first harmonic. Well, the first harmonic here looks like that, and the first harmonic there looks like that. If they have the same first harmonic, they have the same size football. Now, you were told in that problem that tube B, the one that was closed, had a length of 0.4 meters. Well, that's the size of half a football, if I'm playing that note. And so this would also be 0.4 meters, which means that A has to have a length of 0.8 meters. It would have to be twice as long. It's got the same note, same size footballs, it's just got twice as many footballs. Okay? Now, we don't usually want to double the length of our footballs. Usually when we're tuning, we're just trying to make the frequency a little different. And so we would just lengthen the tube a little bit or shorten it a little bit so that the frequency would change a little bit. See if your neighbor understands why flutes don't have strings.